Yeah, thanks everyone for coming. I'm James. Today I'm going to be talking about launching Sentient NFTs and like leveling up DeFi through automation. So quick format of how I was planning on going through this. So like a bit of context about Autonomy as a automation protocol. Then go through some of the kind of like DeFi applications like limit orders, stop losses, self-liquidations, that kind of thing. Then our Auto App Store, which is kind of like a no-code UI for automating things like rebalancing portfolios or like auto compounding, like yield farming stuff. And then I'm going to go through like NFTs and how we can create NFTs that are like fully autonomous and essentially can like transfer themselves. But I can like change this, like focus more on like stuff you guys are more interested in. I guess raise your hand if you're more interested in like the DeFi stuff or the NFT side of things, like auto transferring, or like the no-code like App Store. Cool. Okay. Yeah, I'll focus more on the kind of DeFi and NFT stuff. So like a quick bit of context. So Autonomy Network is a decentralized automation protocol. So we're a tool for dApps to add features like DEXs can use us to add like limit orders and stop losses. That's the main kind of like economic use case at the moment. But we're also about to launch a game, which will be the first case, like the first example of these like NFTs that like transfer themselves and that kind of thing. But yeah, so no shit. So yeah, autonomy itself is like pretty inevitable. When you look at the kind of evolution of applications in the blockchain space, every new kind of wave of innovation, like DEX aggregators, yield farms, etc., requires an innovation in the kind of underlying infrastructure. And so, like DEX aggregators and yield farms require things like Uniswap and like Compound and lending platforms, etc. And this kind of new wave of advanced functionality like limit orders, recurring payments for DAOs, etc., requires an automation protocol like Autonomy. So like the general problem being solved is that humans are not 24/7. Like you need to sleep and work and all that kind of stuff. Like you can't be at the computer 24/7. So that means that you can't set a stop loss on Uniswap. And so like if you can't be at the computer, you're like exposed to all this risk. And for dApps that want to add these features, there's no kind of off-the-shelf solution. Like they typically have some like centralized model of doing it where you just hold a signed transaction on a server. Or, I mean, it's like typically like very custom and costly. It's like typically off-chain, and so you can't use it for other use cases. Like if you have some like auto compounding thing, like you can't use it typically for like limits and stops, etc. So yeah, Autonomy is a tool for dApps to add features, like DEXs can use it to add like limit orders and stops. And so for users, it provides like, users shouldn't even need to know we exist. They just go to a dApp that implements us, and they can just use the features that they expect from like centralized counterparts. Like they can use limits and stops, etc. on DEXs the same way that they can on centralized exchanges. And for dApps, it's an off-the-shelf, easy-to-implement solution. So it can be used to automate like literally any action, on-chain action with any on-chain condition. And yeah, no need to run like bots or servers or anything like that. So it basically works in like 3 steps. Like the user makes a request, which is the only transaction that they make. For example, to sell ETH at 4K, the condition becomes true later, and a bot from a decentralized network of bots executes this request. So you have this kind of like external triggering mechanism. So yeah, anyone can run one of these bots. So that's why it's a decentralized network. It's incentivized. A user pays a fee to the bot, small fee based on gas. And running one of these bots requires staking auto. So there's like a mini like proof of stake algorithm that's used to determine like who can execute what at what time, so that you don't have these like race conditions that end up in like a very kind of unrobust network. So yeah, I mean the flow for like selling ETH is like user makes a request to sell ETH for DAI, like the condition is met, and a bot executes it. Like pretty straightforward. So for limits and stops, let's dive a bit more into it. I'm just realizing on this demo, there is no. That's okay. There is no way to do it, but I can shoot it up on here. So just give you like a feel for how this works. This is a DEX that integrates us to add limits, and so it's a pretty familiar interface, like kind of like Uniswap, but just with an extra like price condition. So you take some input token, some output token. Here we just get the current market price and require that the amount that we want is slightly above the market price, just so that it's like takes very little market movement to trigger it. And so the user makes one single transaction, and that's the only thing that the user does, and it will pop up in the Open Orders tab. And then we went and like pumped the token, which triggered the execution. And so the user got their tokens, and it moved from the executed tab into the from the Open tab into the executed tab. So the UX is like pretty simple, and so like the user doesn't need to know anything about autonomy or how it works or anything. I guess I can. I think these slides, the slides on here are slightly outdated, so I'll just go from here. Because I finished these slides quite late, I'm not gonna lie. But yeah, so I can take you through like a little bit of the code of kind of how how you can like create things like limits and stops through Autonomy. And so like this is live on autoswap.trade and like that example that I just showed you, and that the code is public at this repo. But yeah, so this is just like a small like code snippet from God, where's the mouse? I've lost myself. Oh, there we go. Yes, this is a small code snippet, and it's just like making a token transfer. Sorry, a token-to-token limit order. And like generally, what you want to do is wrap some target system and add a condition. So in the case of like Uniswap, you basically create this wrapper contract that calls everything one-to-one. And so this is the like in Uniswap, there's an ETH to token, token to ETH, token to token like trading functions. And so this is just the token to token. And these are just some helper functions. You can ignore them. Like this is the main like business logic, and you can see here that this basically just calls like Uniswap pretty much one-to-one and adds this require condition. And so it's called token to token range because we can use it as both a limit and a stop, because like a limit is just where you have like a minimum price, and a stop loss is just where you have basically a maximum price and are willing to accept anything below it. And so in the case of a limit, you have like the amount out required to be some minimum, and just like amount out max would be like the max integer or just some obnoxiously high number. And for a stop loss, like the amount out max would be the kind of like stop loss price, and amount out min would just be like one way or 0 or something. Fortunately, Uniswap actually includes a requirement about the output because they use it for like preventing slippage and preventing front running and that kind of thing. So that's one less thing to do in this particular example, but they don't have anything to do with like a max price to implement like a stop loss functionality, and so that's why we have to add this require statement here. And so you can see that like this just basically calls everything one-to-one in Uniswap, obviously like with all the other ETH token functions, etc. And you're just adding these conditions. The thing is, like with Uniswap, when you try and execute a trade, if the price is below the minimum, then it'll just revert. But this decentralized network of bots are constantly simulating requests like locally, saying, okay, if I try and execute this now, will it revert, yes or no? And so they only broadcast it when the condition is fulfilled, which in this case means the price condition is fulfilled, and this secondary like max price too. These help functions just basically like take the tokens from the user because they Uniswap, assumes that the message.sender, which in this case is like this contract, has the tokens, and so you need to call approve on Uniswap. But you may notice that when it takes tokens from the user, it doesn't just take it from message.sender, and that's because message.sender in this case is like the autonomy contracts. There's essentially a registry which is like the entry point for users and for bots, and like all the routing. And so you may think that this is like an obvious kind of security vulnerability, that you essentially have the user as input, right here, because, couldn't you just use an input, like a different user, and essentially like trade with their tokens and therefore steal their shit? But we use this modifier here, which essentially requires that the message.sender is a special contract called a forwarder. And so a forwarder is essentially something that just, like it says, just forwards a call. And so when creating a request, there's this flag called verify user, which, the user doesn't need to know about. The UI just takes care of it. But when this flag is false, like the call will just go straight from the registry contract to the target system, which in this case is this contract. But when verify user is true, the call will go to the forwarder and then onto the target. And so message.sender from this is the forwarder. And this, just before forwarding this call, it checks if the first argument of the call data being forwarded is the user, because the register knows who the user is, because they made the request through it. And so if you require that the message.sender here is this particular forwarder, and calls only get sent to this forwarder if the user is correct, then therefore you can be guaranteed that this user here is the kind of like the real user who made the initial request. And so you're just like forwarding information to do like user authentication, essentially. So that's like basically kind of how you automate any like general action. Excuse me. We also have like a no-code interface. Shout out to Diego. And so let me zoom in. So the idea here is this would be to be a kind of like app store of automation, in the sense that you can, like without writing any code, just automate things by like taking building blocks from other people, like other people's conditions or other people's actions. And so let me move to. So this is an example like target contract you may want to automate. These can be like compounding yields from a yield farm, or like sending payment, or really like any arbitrary thing. And so you can just like chain like multiple different actions or conditions. But here I'll just like remove these just for the sake of simplicity. So you just paste in an address, and it'll come up with all the kind of functions that can be automated through this. So this just has like a variable x. And say we want to increment x, which is like obviously just like a test case, but this could be compounding or like rebalancing some portfolio or something. So we want to automate that. And so this like preset is the kind of like where the app store kind of thing comes in, where there are these like presets, pre-made conditions. And so in this case, we just have like based on time. So we could say we want this to execute, let's do like a minute from now. And so like this increment x will only be called between these two time periods. Give it a name. And so we essentially just make like one request. Right now, this contract's like X is. Can I zoom in here? X is 24, and so there's a bot network like running. You can see So the new request was made, and actually, because I took like a minute to actually like submit this thing, it was basically executed immediately. So we can look at the timestamp. Yeah, within the time range. And so you can, yeah, basically just like chain an arbitrary like number of things and conditions. Like maybe you only want to like rebalance a portfolio when like some address is above some balance. But yeah, so we can move on to the whole NFT thing. So like, what are autonomous NFTs? So like using autonomy, like we can automate a single action, like a limit order. You know, after the limit order is done, like that's it, the request is executed. But you can make like recurring requests, and so we can make any contract therefore like basically autonomous. And therefore, it's like since an NFT is a contract, we can make an NFT autonomous. And so we can make NFTs do things like transfer themselves around. So how does this work? So autonomy, like NFTs are essentially just like a standard, you know, where they implement some interface. You know, it's like owner of, and they have transfer functions, etc. And so if we want the token to be transferring itself around, then we probably don't want the owner to be able to transfer it. So we need to have this like separate concept of kind of like owner and the thing that can control it. And so like, I need a better name for this, to be honest, but I just called it like the brain, where the brain is the thing that's actually controlling, you know, it can transfer the NFT to different owners, but the owners can't actually transfer it themselves. And so the brain essentially like talks to autonomy to make a request, to ask that that its own transfer function is called, you know, under like arbitrary conditions, like say every day, or it can be like balance based. It could be due with the price of oil, or really anything. And so there's essentially like two transactions, where one where the thing is like the request is created, and so because you're doing it through a brain is a separate contract to the NFT. In this, because you know you need a different address, the same way that like owners, you know, are not the contract address of the NFT. Anyway, so this essentially like routes a call through the brain that then makes a request in autonomy, and then when the condition is fulfilled, like, you know, based on time or whatever, like the bot network will trigger the execution through autonomy. Autonomy will call the brain to do whatever, in this case, transferring the NFT. And so it'll call the NFT to transfer it. And this can be done like arbitrarily many times. So I can jump into some code quickly to give you a feel for how this works. So I have an example of like the NFT and the brain. So this is the transfer function in OpenZeppelin, and this is like our modified version, and it's literally just like a super simple like change. Instead of having is approved or owner here, we have is approved or brain, so that is approved or brain, so that being the owner has no like won't, you know, allow you to like transfer this token, but being the brain will. So you have like a mapping of like token ID to owner, and the same way you have a mapping of token ID to the brain. And for example, like a brain code might look like this, where this is kind of like transaction one that I was talking about just a minute ago, where you, like, this is what the user calls. This is the brain, and all this does is essentially call a function in the registry. It's basically to create a new request, and it's hard-coded that the target contract to be called is this contract. And the call data that you want, in this case, is this function. So we're essentially saying like, I want to call this contract with call data corresponding to this function and all these inputs that you want for this particular NFT. I mean, you can ignore the rest of the inputs. It's not a big deal. And so that's the first transaction, and then the second transaction is triggered by Autonomy. And so you have a similar kind of like verification thing here to ensure that the person who requested this is this contract. Who's trying to execute this is this contract. And so this is stuff to do with like basically making it so this calls every time period. This doesn't really matter, but yeah, the kind of transferring itself part comes in here where this just gets like a random person to transfer it to, and then yeah, calls transfer from in the NFT. And despite like even if new owner is not this contract address, it doesn't matter because like this is the brain transferring ownership. And because you need to pay for execution of requests, like in Autonomy, you in this case, it's assumed that this essentially just has like a pool of ETH that it's using. It knows through fee amount. I didn't really go into like how this is guaranteed, but it's kind of guaranteed to be accurate in the same way that the user address is guaranteed to be accurate. And so it knows how much to pay, and at the end, just pays the fee. So we're actually gonna we're creating a game that it's called Meta Dungeon. There's a bunch of firsts in it. Like the relevance to Autonomy is the fact that this is the first time NFTs will be able to transfer themselves. The use case we're using here is them to be like non-playable characters in this game, NPCs, which is the first kind of ever like true NPC in a crypto game. Because generally, crypto games have basically been like player versus player, and it's for this reason, I think, because you can't really have like proper NPCs. Like you generally like, because you need to interact with something in order to change the state about the blockchain. Like typically before now, that basically means that the NPCs suck and they don't do anything. They don't interact with each other. They don't interact with you first. And so this is the first time that like this functionality has been enabled. And so there's essentially like two sets of NFTs in this game, like players and these bosses. The bosses transfer themselves to the wallets of players randomly. And if it's in your wallet, then you can fight it and like win tokens and NFTs that it holds. If you lose, then you use a power-up, you lose the power-up, like an NFT. And so it builds this like prize pool over time that's kind of like self-sustaining. If it's not in your wallet, you can do things to summon it, like spending an NFT. Or we have this like team play functionality, which also makes this the kind of, I think, first like collaborative and team play game in crypto ever, which is kind of cool. But the relevance to Autonomy is like the ability for these NFTs to kind of like autonomously like control themselves and do things like respond to players, like initiate interactions and that kind of thing. And yeah, that's basically my talk. So yeah, does anyone have any questions or anything? No questions. No questions. Stunned silence.
Well, you're talking about the meta dungeon game. So like the NPCs are just triggered to just be sent randomly to players' wallets.
Yeah. So like like I said, there's two sets of NFTs: the player NFTs and the boss NFTs. And so because you essentially have like an on-chain list basically of players, which is the owners of X number of player NFTs. So yeah, that's what it does like right now, and it can be used to do like way more complex stuff.
All, like, through the brain. The brain is just
Yeah.
controlling that because now no one has to approve an NFT being transferred. It's just the brain itself.
Yeah, exactly. Like this function is just being called like over and over again.
Okay.
Just yeah, pretty much. Yeah, thanks. But yeah, if there are no more questions, then yeah, thanks for coming. I've been like slightly dying because like my throat's sore and slightly too much partying, but other than that, yeah, cheers guys.